So yeah, the bug from yesterday, I did some experiments. It's a bug with the programming language.
Okay.
Yeah, it's a bug with the programming language. So you did nothing wrong.
Finally,
I,
not my fault.
yeah, it's not your fault. It's like this is very rare, by the way. I guess this programming language is still young, but generally speaking, it's very rare to like run into the bug by the programming language. Like in C++, as long as you're not like on a very, very new version, uh, or like I've never ran into a programming language bug my entire life. Like that was my first one.
Hmm.
Yeah. Anyway, yeah. So yeah, that was kind of funny. All right, I'm gonna run it now. Let's see if it runs. Oh wait, I have you been? Oh, you're working on Chopin as well.
Yeah. So
Okay. So I'm gonna.
I didn't start like doing anything. I just write it the test.
Hmm. So what you can do, right, is just make it return the same thing like ML. So I'm gonna do that line 592 ML. So that way, at least we can
Okay,
run a
okay.
program. The test will
Yeah.
fail, except for somehow two pass. But yeah. Okay. So yeah, it looks like Taken is good. Let's take a look at Taken. Okay. Uh,
Uh,
Emily's
I
cut
use the
after.
temp because temp does nothing, but it stops like the function from returning to things.
Ah, okay. I believe there's another way to do this.
Yeah, I checked in pirate uh
Hmm.
docs, and there is something called block,
Yeah.
and it doesn't return nothing, right? It
Uh,
just does
it
things.
it evaluates to the final expression. So you
Okay,
can have
okay,
multiple expressions and it varies to the
okay,
last one. Yeah.
okay. Makes sense.
Can I try it real quick? I don't know if this is gonna work.
Of
So I'm
course,
on
yeah.
line 564 right now. Let me see if this works. Yeah. You see that?
Okay, okay.
So
So,
we label the if as a block. So it can run multiple expressions, and the last one on line 567 will be the run that gets evaluated. Uh, yeah,
okay.
there we go. You learn something new. But you don't have to worry about this in C++.
Yeah.
Okay, let's look at cut after. Uh, NMT and link vref. So yeah. So yeah, again, 545, we can also
Yeah,
use
yeah.
block.
I didn't know how to use that, so
Hmm.
I did it my way.
Hmm.
Yeah, so it returns what is after like the uh final index, right? That we are passed to
Okay.
it.
Okay, I don't want to talk about this here yet. I'll save this for next time. But notice how there's a lot of similarities between take n and cut after.
Yeah.
There is a way to remove the duplication, but we need to go through techniques that you haven't covered yet, and that won't be relevant to competitive programming.
Okay.
So I'll just leave a note on that, that there's a way to abstract. Remember the abstraction recipe?
Yeah.
Yeah, so we need to apply the abstraction recipe, but for data. But yeah, that's next time if you're interested in that kind of stuff. Uh okay, yeah. That's I'm gonna create a new file. I'm gonna go to a new topic.
Okay.
So we're gonna go away from mutation for a moment because this new topic is also quite tough
Okay.
and it's directly linked to competitive programming, so it's time to focus up. So to
Okay.
summarize what we've done, we have explored the design recipe. So let me go through what are the design recipes we saw. We saw one for data definition. I mean gr.arr, by the way.
What?
I mean gr.arr,
Yeah,
the
yeah.
file. Okay,
I
okay.
know
Just
that.
making sure you're here with me. Okay, we
Yeah,
saw data
I'm just like
definition.
w watching your stream, really.
Oh, okay. We have data definition. We got one for functions. How do you design for functions? We saw for abstraction.
Yeah, that was the last one, right?
There's one more.
Uh,
Accumulation.
accumulation, right, right.
Today, we'll cover the last one. So there are more design recipes, but these are like the fundamental ones. So like fundamental design recipes. There are more advanced ones, but we won't go over those. We are gonna go over this question mark here, okay?
Okay.
So for this case, I want you to use the list the pirate list. This is the immutable list, and I want to use their library functions.
Okay.
So don't use your custom map or fold or whatever. You use the ones they give you. And
Okay.
there'll also be other functions that can help you. I'm not going to tell you what they are because I want you to solve the problem. So here's my task, okay? So implement mystery sort. Here, here's the algorithm outline. Okay, so I'm going to give you the outline of the algorithm. Given a list of numbers, take the first one. Oh, wait. Sorry. So, okay, wait. Okay. This algorithm sorts the given list of numbers.
Okay.
So, if the list is empty, I swear to God, like whenever I'm typing a Visual Studio code, my keys don't get registered. I'm gonna type with typos. Just keep that in mind. If the list is
Yeah.
empty, uh, produce the same list.
Lis is like fox in Polish.
It's what Fox? Fox?
Fox. Yeah,
Oh, that's
yeah.
funny. Okay. Uh, otherwise, take my T is just broken. Take the first number, gather all the numbers. Oh, take the first number, call this the pivot. Take all numbers below the pivot and sort it.
Are we doing quicksort?
Okay. Sorry, what sort?
Quicksort.
Shit, okay, yeah, it's quick sort,
Yeah.
okay. It's no longer mystery, it's quick sort, yeah. I was trying to be mysterious, but
Yeah. Sorry. My
it's
fault.
okay. Sorted.
Pretend that I didn't say that.
Yeah. It was meant to be a surprise, like, oh, this is actually quick sort, but no, you already know it's quick sort. Um, then merge the three, merge, okay, sandwich the pivot in between the lower and upper list, if that makes sense,
Yeah.
and produce that list. Okay, I would like you to follow the design recipe to the best of your ability to implement this.
Okay.
I'm gonna fix my typo now.
Hmm. Okay. So yeah, we should switch to. Wait. Uh, takes a number, right?
Yep. You can integrate the signature into the function header as a type.
What?
Yeah, it's okay, keep going.
Okay. I like to do like camel case.
Really? Okay.
Don't you like to do that? Yeah.
Uh, I do in C++, but not here because like the library functions are all like hyphens. And then, if my functions
Okay.
are, yeah, but it's up to you. It's up to you.
Okay. I'm like was really distracted with the hyphens.
Hmm.
Mm. Mm. Okay, I should like write that. Did I write ascending right?
Correct. Yeah, that's right.
Finally, yeah, I learned something.
Okay, so technically, right, you might sometimes hear the word non-descending order.
Okay, makes sense because
because I think it's to include like numbers that are the same.
but
But
there is one problem with that.
uh-huh.
I don't know how to write descending.
It's like the same thing, but instead of A, it's DE. Yeah. So
Oh,
it's
okay.
ascending, but replace A with DE. So you're
Okay.
missing the S before the C.
Okay. Makes
Yeah.
sense. Mm, mm. Was it called like empty? Yeah, I suppose.
Yeah. So yeah, you have
Yeah.
to pull up the documentation. You'll definitely
Mm,
need a documentation.
okay, wait. Can I like pirate list? Thank you. I will. Okay. Yeah, was called empty and link is link. Okay, it's empty. Nice. Love that. Okay. Okay, dot filter was called dot push. Okay, interesting.
Oh, you're looking at the functions. Yeah, you may use any of those, and you're encouraged to.
Okay, thank you. Mm,
Yeah, I'm gonna share my screen for people online to see the documentation.
mm, mm. Are these cases enough? Like, I don't.
Uh, so I'll personally have like a list with one item.
Okay, makes
Yeah.
sense, makes sense.
So yeah, generally you want to start with the most simplest case and then gradually work your way up. So one item, then two
Yeah,
items, then only three. But
okay,
we can start with one item.
okay. Because like I have created a list that is already sorted, right?
Yeah,
Makes
the
sense.
identity that's good.
Yeah. Mm, okay, so cases. Uh, the syntax was like this. My keyboard is uh, dirty, right?
Hmm. Same.
Mm, oh, the first element should be the pivot, right?
Oh.
Yeah. Mm, what was the? I must look like the filter. Sorry, the
Hmm.
syntax for the filter. Uh, filter. Uh, dot filter. Uh, okay. Wait. Filter it boolean. Okay. So um, number of x, right? Was smaller or equal to the lot. Okay. Return pixel.
Nice try.
Nice try.
Oh, you don't need the angular brackets number.
Yeah, makes sense. Mm.
So how long should we wait for?
Ah,
Start terminating, right? Okay. So let's pause here. Okay, so first thing is we actually do need the angular bracket. Okay, not we don't need it, but it's good to have the angular brackets for number in line 24. But number is already a type that exists. You don't have to put it next to quicksort, right? It's not like
okay.
X.
Yeah,
Yeah.
yeah,
And
okay,
same for
okay,
the
okay.
resulting type. Okay. So the next topic we're going to introduce. I didn't expect you to complete this, by the way, because I didn't introduce the ideas that will help you complete this. I wanted to get your experience on your own first. Is this following the list template?
The list templates.
Yeah. Is this following the list template?
Mm, it is not, right? Because
Why is it not following the list template?
first of all, we are like calling twice or the same this function, right? Right. So we are doing the recursion twice,
Okay.
and uh, hmm, we are doing like something with the pivots twice, right? Like three times. But it doesn't matter, I suppose.
Um, that's actually we're allowed to use the first element as many times as you want.
Okay, okay.
The list template allows that.
Mm,
Why are we recurring twice? In the list template, what do we usually recur on?
wait. What happened?
What happened?
I have like gray screen all over my pirate files.
What?
Wait. Can you
Do you
like
want to
save the file? Save the file?
like me?
Yeah.
Both files, ACC as well?
Okay. It's okay now. Yeah,
All
I
right.
have reopened it. Okay.
Okay. All right. So in the list template, what's being recurred on?
Mm, the rest, but
Yes.
Oh,
list
I
template.
haven't used even the rest.
Okay, so that's one problem.
Yeah.
That that's actually I think if you
Okay.
fix that it'll be a lot better. That
Uh,
might actually just fix it. So actually, do you want to do that right now? That wasn't the
uh,
point I was trying to make, but you can fix it.
yeah. Mm, so like that.
Okay,
Yeah.
there we go.
It's
So yeah, no, that's the simplest thing, right?
yeah.
So
It's significant. Yeah. It's much faster. Yeah.
yeah,
Easy
much much
words. Easy
faster.
words. Easy words. Just
Yeah.
don't
Okay.
use complex words.
But even so, we're still even when we fix L to R, it's still not the list template because we're not recurring on the rest. Okay? But here we recur on new list. Like
Mm,
it's like what we're recurring on is like a completely new list. It's
yeah.
not even a
Yeah.
sublist, right? It's elements taken from the original list, but they could be rearranged. So it's a new list.
Yeah.
Okay. So what we saw with the list template is called structural recursion. Okay, I don't want to like give you bad spelling because I don't want to influence your English spelling,
Okay.
but my
Okay.
keyboard's being really funny right now. Okay, okay, so it's called structural recursion. That is recursion
Hmm.
uh happens with the structure of data.
Okay. Okay.
Yeah, my T is
Like,
oh my God, my
okay.
T is like busted. Dude, I'm not gonna use my key. I'm just gonna use my laptop keyboard to type. Okay.
Oh, you use like
I
laptop
have a plug-in
also.
keyboard, which is supposed to like improve my
Mm.
productivity, but now it's just hindering me. Okay.
So
But
we are
here,
like we have matching.
yeah. Here we are not recurring on the structure of data. Instead, we're recurring on generated data. Okay?
Okay. Okay.
We are generating new data.
Yeah. Yeah.
Thus,
Yeah.
we call this generative recursion.
Okay. Okay.
So I'm going to scroll back up to our fundamental design recipes. I'm going to replace the question marks with generative.
Okay.
This is the final piece to the
Generative.
puzzle that will be very important
Generative.
for competitive programming. Because in competitive programming, the data they give you isn't always beautiful. In fact, they're going to
Mm.
give you a list of numbers. But the structure of the problem is more complex than a list of numbers, right? Like here, the
Yeah.
structure of the problem
Always.
is we need to like filter for smaller and bigger numbers, that's
Yeah.
more complicated than the structure of numbers. And so we have to use generative recursion to generate new data. So
I
in
was
competitive
actually
programming,
okay.
yeah,
Yeah.
sorry, go on.
I was actually horrified that I didn't do that correct because I like in classes I did that I did quicksort in like three different programming languages. So I was
Um,
like,
I think that's like complacent. Okay, I think there's two problems. You face two problems. The first one is complacency. You got so confident that you weren't thinking very
yeah,
hard. The second
yeah,
problem is that you weren't thinking systematically.
yeah.
S- which is why when I teach programming, the main thing I'm teaching is actually systematic thinking. You're thinking with steps, being very careful between each steps.
Mm,
Yeah.
okay.
So the fact that you weren't using R rest should have rang alarm bells like, oh, maybe I should be using R.
Yeah, yeah.
And also, I don't blame you because when I gave my algorithm, I didn't specify that the pivot should be excluded from the lower list or upper list. In fact,
Yeah,
I didn't
that's
specify what to do with pivots with the same that's the same as like so yeah,
yeah.
so it's also like part of it. The instructions I gave is also deliberately ambiguous. Okay, we call this generative recursion. So in generative recursion, because we are not recurring on structure, there is no guarantee of termination. So I purposely wanted you to experience that actually. So it's good that you did. We are now capable of writing code that doesn't terminate. When we were recurring on structure, the recursive structure, the structure of the recursive data determine no guaranteed termination,
Yeah, okay, it
right?
makes sense because we are
Because
at some
you can't
point.
have recursive
Yeah,
data without the base case.
yeah, yeah.
Okay. Unfortunately, generative recursion is more powerful. So, so generative recursion is more powerful, but also needs more care and responsibility.
So again, with more power.
Yes, with more power comes great responsibility. I still haven't watched the
Yeah.
movie, by the way. Uh,
Yeah, I didn't also.
okay. I plan to watch it when it comes out on like
Yeah,
streaming.
some yeah.
Yeah.
I think Disney is going to stream that.
Yeah, after like maybe 10 years, once everyone has
Yeah.
paid theater money. Okay.
Yeah, the
Okay.
same as Avatar. Yeah.
Yeah. Uh, okay. So we're now gonna go talk about the generative design recipe.
Hmm?
Okay, this is not quite the recipe. Okay, this we call this the termination statement. So with oh sorry, my shortcuts are different on the small keyboard. The generative recursion requires a termination statement. In this statement, you need to specify the following. What are the base cases? You need at least one. So sometimes you have multiple, but you need at least one.
Okay.
And in mathematics, so I also talk in programming, we refer to this as base cases. In more formally, they're actually called trivial cases. They are
Yeah.
called trivial cases. There's a mathematical meaning behind trivial, but people are just going to say base cases. Uh, Second case is what are the recursive cases?
My teachers call it trivial. Yeah.
Trivial. Okay, yeah, that's the
Yeah.
formal
Yeah.
in formal education they normally say trivial. What are the recursive case? Oh yeah, so notice how like in school you probably learn this is one of the first things you learn, but this is one of the last things I teach.
Yeah.
So like all the care and thought that I built up so far, all the different recipes build up to this point because I believe that generative recursion is the hardest. You need to be most prepared. So my opinion is that a lot of schools they aren't preparing students enough for this.
Yeah.
Yeah. Anyway, yeah, what are the formally cases? Formally, you may hear this as I believe it's complex. Sorry, let me check the terminology. I believe it's called complex. Let's see. I'm reading the textbook right now. What's it general? Bro. Why is this textbook so many words? I don't think I don't think that's a formal name actually. Okay,
Oh,
forget the
okay.
name. I don't know if that's a formal name for this.
I
Uh
want to remember it, so it doesn't matter.
Sometimes you may hear complex cases. I believe it's complex. Uh and then you need to why are the recursive cases guaranteed to reach the base case? Okay, so now I want you to scroll back up to quicksort and I want you to answer these three questions for quicksort and I want you to write it as a comment under line 23.
Mm, okay. Mm.
Oh,
Okay, so okay, I will write that right. What line?
Underline 23.
23? Yeah.
23, yeah.
Okay. Mm, I will copy them, okay? So you know
Yeah.
what questions I am answering, right? Uh, so can I like use really short answers?
Yeah, sure.
Okay. Mm, mm. So like this, right?
What are the recursive cases? No, you need to use more words. Like it's link pivot R is not recursive, right? It's just
Okay,
yeah.
okay, okay,
Uh,
okay.
like given a list of like given a non-empty list, what do we do with it? Yeah,
Mm, can I can I write that?
sure, yeah.
Yeah, okay. We
Okay. So I think we can stop there. We don't have to say we combine blah blah blah. Let's move on to the
okay.
third question now.
What are the recursion guaranteed to? Uh, read the first. Mm, hmm. Okay, so like uh, rest at start starts with. How to say shrunk? Like,
Okay, just say get smaller, right?
yeah.
Okay, yeah. So here's how I would, so you are correct. Here's how I would phrase it. I would phrase it differently. So these three questions, I don't expect you to literally like answer one at a time. But there are guidelines to help you think. But here's how I phrase it in one sentence. Uh, the trivial, oh, okay, sorry, I can't use my fancy keyboard. The trivial case is the empty case. Uh, given a non-empty list, it's guaranteed to uh given a non-empty list that generate data, the generated recursive data. So that's referring to the generate. Yeah, you know what I mean, right? The small and bigger are
Mhm.
guaranteed to be smaller. The the smaller list that includes numbers equal to the pivot exclude the pivot, and so is And so its length is guaranteed to reduce by at least one. The larger list doesn't include the pivot, and so its length is also guaranteed to reduce by at least one. Um, uh, Thus, the generated recursive data will eventually reach the length of zero. So, do you actually have to say all, so for learning purposes, I would like you to be able to like write sentences like this because I want you to be very explicit with your thinking. In competitive programming, you're not going to have the time. In competitive programming, you just need to think this in your head. Maybe write some bullet points,
Mm.
right? Yeah. So the error that you made just now is that you didn't have this like formal thinking, right? You weren't thinking, oh, the smaller list is going to exclude the pivot, so the list is going to
Yeah,
shrink by at least one. Yeah. But the key idea here is shrinking by at least one, reducing by at least one, because mathematically that guarantees that you eventually arrive to zero, right?
yeah.
Okay. I'm not going to give you your next problem, but let's refresh the Zoom link. I'm going to send you a new link here on VS Code, okay?
Okay,
All right.
okay.
I'll see you in a minute.
See you in a minute.
All right. So your next task, let's see if I can, is it in the textbook? Ah, damn it. I have to write this on my own. Okay.
Yeah, the
I
holy
don't know,
textbook.
I don't know if you know this one.
Is that mystery sort that sorts a given list of numbers? Okay. Partition the
Sorry, brain fart.
Hmm. What is what is that? Huh? Ah,
Have you seen this before?
ah.
Okay,
Wait,
this is new. Good, good. Okay, very good, good. Okay. All right, follow the design recipe. And if you believe this is a generative recursive function, I would like you to write a termination statement. Good luck.
like uh, is it is it like merge sort, but I don't understand like the thing that you have written?
Wait,
Or
what? Wait, okay.
is it merge
What about
sort?
this do you not understand?
Okay, okay.
Wait, is it a
So
word partition?
no, no, no.
Sorry.
Okay,
Okay.
okay, okay. I have tried the merge sort earlier. You remember that I didn't
Oh,
do
yeah.
it.
Okay. But yeah, okay. Fine. I'll tell you. This is merge sort. This is merge sort.
Yeah, yeah, yeah.
I do remember you saying that you tried it. Yeah. Okay. So yeah, back at it. We're
I
doing it again.
think it's in Sunrise, like the merge function. The function,
Wait, have you implemented?
like only merge. Like I didn't do
Okay.
split. Yeah,
Uh
or I did like split, or
oh
I
freak.
don't
Sorry.
remember.
Sorry, yeah, sorry. But I made a mistake. My instructions, I shouldn't pen them together. I should merge them together. Okay, yeah.
Yeah.
You may copy in your merge code if you like.
Okay.
I'll allow you to reuse it since you've done it before.
Yeah. Where is it? Yeah, I must translate it too. Right. Uh, and split, right? Mm. I didn't back then. I didn't want to use like the built-in functions, right? So I think now it will be somehow easier. But okay, so mm, I remember what I have like problem with. I didn't know how to return to lists. You are not going to help me, right?
Mm-hmm. Mm-hmm.
Mm,
Um, if you want to return two things, you need to like create a custom structure, but like you don't really need to do that for this problem.
yeah. Uh, I
Yeah.
do. Okay. I do not need that.
Yeah, you don't need split. Okay, okay, remember what I said last time, like solve the main problem first. When you see a helper function you need, only then would you create it. Like don't try to predict the helper functions.
Uh, of course, of course. Sorry, my bad.
Okay?
Mm. Even list of numbers by doing inverse sort. Yeah,
Okay.
inverse sort. I cannot type. I just copy the cases. Of course, I didn't specify that. Okay. Mm, wait. Do we need cases? We don't need cases, right? Yes. Uh, how to check the length of the list.
How do we find out?
Uh, length, dot length, of course, dot length. Uh, uh, just like in C++. On strings, of course, on strings. Mm, what should we return? You said, of course,
Should
our,
you write the termination statement first?
the termination statement.
Yeah.
So, like the three questions that you have.
Yeah.
Mm. In the way that you have written it before.
Up to you. I just want you to be thinking about this.
Okay, okay. So, mm, How did you start it? Okay. I know why did you say that? Because we cannot assume that it has one. Okay, okay. I will write the termination. Contains.
Okay.
Mm, what are the recursive case? Mm, mm. Okay, so mm, and then sort bow the uh, receive. Mm, what are the recursive? Mm, uh,
Well, what happens if we have like, is it possible to have one list that's full and the other list is empty?
uh, it's not right. It's not
Why is it not possible?
because the split function splits the list into two almost same length, right?
Okay. So
Mm.
for list at least two, that means that the smaller list is at least one, right? Like
Yeah.
mathematically speaking, when the list is at least two, the smaller list is at
Mm.
least like one. So that means the lists are guaranteed to be smaller. So yeah, that's a part of the explanation that needs to be said here.
Yeah. Makes sense.
Yep. Okay. I do want to say that there are some things here that you could cut. So I'll specify what you could cut in curly brace. So when the list contains one or less elements, because it, okay, it means the list is already sorted. I would say like you don't have to say that. Like as long as you know it yourself, that's fine.
Okay.
But since it's already given the problem, that's your base case, so you don't have to say that. If the list is at least we split into two halves. So all like we split it into two halves and then sort them both of them recursively imaginary, and that could also be cut. Uh the recursive case that will guarantee we won't have all this can be cut. The split is divided into two parts. So I would say like only the last sentence is really necessary. Let me change
Okay.
let me change my instruction. So the second case, what are recursive cases? I think it's better if I say that why are the what are the recursive are the generated recursive data? I think that's a better way of phrasing my second question. And why are they guaranteed? Why are we guaranteed for each base case? Yeah. Okay, yeah. Okay, you may continue. I do also want you to write the test first, just to have that habit. I think the tests are very
Mm,
easy for this case. Yeah, you know what? You can copy it from your previous one, actually.
yeah, yeah, I can. Right. Just
Nice thing
change.
about sort. Oh, I do want to add a list with two length two, because that's the
Course.
simplest complex case, right? List of length two.
Yeah.
Yeah.
Mm, uh,
Okay, cool. All right, we have a termination statement with our test. Let's do the body.
mm-hmm. And okay, okay, okay. Uh, is there like some, I don't know, tuple that we can store the both halves in Pirate?
So can you repeat the question?
Like, is there a special type of list, maybe a tuple or something that we can?
Oh, yeah, you can just have two variables, right? I mean, you can have a tuple, but why not just have two variables?
Uh, hmm. How would I like? Oh, oh,
So read the documentation, see if there's a fu library function that can help you. If not, you have to create your own.
there's a split at. Okay,
There is.
yeah.
Oh,
It returns a tuple.
dude, I'm not gonna lie, I didn't even know this was here. Okay, wow, your life is very easy.
Yeah, yeah. I suppose
Okay,
it. I
yeah, my
suppose it
bad.
is.
Okay, yeah, to answer your question, yes, there's a tuple, and you'll need it.
Okay. Wait. How do how do I use uh okay, so the okay is prefix, okay, suffix. Uh
I don't like that. I just
why?
found out how to access a tuple. Looks like crap.
Why?
Are you looking at it? Do you know what it looks like?
Y- Yeah, it like dot and then curly braces and the
Yeah,
index, right?
yeah. I don't like that.
It looks horrible, right?
I don't like the look of this.
Uh,
Okay, yeah, so yeah, so yeah, by all means, use the tuple. I did not realize that function was there.
okay, okay. Uh, so I can like uh want this like Okay, it will give me mm, how to like floor it. Is there a function to floor
I
something?
believe so. I do not know the name, so you have to look into the numbers library
Yeah,
documentation.
I'm looking. Non-floor, of course, is with the hyphen.
Okay, we are out of time. I have my full confidence in you that you can complete this. I want to mention a few things. First, notice how the split add it returns a tuple of two things. But remember
Yeah.
when we did take n, right? Take n was doing the same thing.
Uh, yeah.
Why is it that we can only return one? Take n can return one thing. So don't answer it now. Why our take n? Oh man, my keyboard. Okay.
Okay.
Question number two is so if you have time, it's okay if not. Right,
Yeah.
create two implementations of yeah, you may keep writing, that's fine.
Okay. And
Um
I did not close that. Uh, okay. I
you just solve it?
I don't think so.
Okay.
Uh,
Okay, so I'll leave you in your devices. I've given you some questions below. If you have
okay.
time, you may work on that, but we'll pick it back up next time. All right, good work, Simon. I'll
Yeah.
see you next time.
Okay. Thank
All
you.
right,
See
bye-bye
you
now.
tomorrow. Bye.